Today, in preparation for sections 1.5 and 1.6, we will be talking about distribution, combining like terms, and interval notation. So to start with example 1, we will be distributing different values in order to simplify the expression. So for this first example, we have -4 times x minus 7. So here we're going to want to distribute the -4 to the x and the -7. And this gives us -4x, and then we have minus -4 times 7. You don't have to write it like this every time. You are welcome to simplify the negative times a negative, which gives us a positive. So we get -4x plus, and 4 times 7 is 28. Now we're going to do the same thing on this next example, where we distribute the -3 to all three terms. And this time I'm just going to go ahead and multiply out that negative times a negative. So here we get -3 times 2, which is -6x squared. Now I have -3 times -1x, because remember there's a hidden 1 right in here. And that is plus 3x. Then a -3 times a plus 4 is a -12. That's exactly what that one looks like simplified. Now this last one, you see it written here as one line. Most often we see it written as two lines like this. And when we do this, it's still the distribution property. The 4 is going to get distributed to the 12 and to the 8. So this is the same thing as 12x over 4 minus 8 over 4. And that gives us 3x minus 2. 12 over 4 is 3, and 8 over 4 is 2. Moving on to the next one. We are going to be combining like terms here. So like terms mean that the exponent on the x's match. So, for example, 3x squared and minus x squared are like terms, whereas 5x and 2x are also like terms. They have matching exponents on the x's. It's the easiest way to tell. And so we can actually combine their coefficients, the number in front of them, to simplify. So if we have 3x squared minus x squared, that gives us 2x squared. And we have a plus 5x and a plus 2x, and that gives me a plus 7x. Now for the next one, we have a couple different distributions to do. So first off, we need to distribute the 2x to the x and the 3. And then we need to handle this negative in here as well. So to carry out that first operation, I have 2x times x is 2x squared. Now I have 2x times 3, so that's a plus 6x. And now I need to distribute the minus to each of those three terms on the right. So that looks like minus x squared plus x, since I have a minus times a minus there, and then minus 1. One of the most common mistakes I see is people forgetting the parentheses on this second term. So from here we can combine like terms, and we have a 2x squared and a minus x squared, so that's x squared. Now I have a plus 6x and a plus x, well that's plus 7x, and I just have a minus 1. So notice I've combined all the ones that have matching exponents, and I've left alone any that don't. All right, moving on. Now, we've seen inequality notation and interval notation. I want to make sure we're clear on how we put that on a number line. That'll be part of the homework this week. So first we're going to look at x greater than 3. So we want to represent all numbers that are greater than 3. So to write that down as interval notation, we want to write down 3, and we're going to go all the way up to positive infinity because we said all numbers greater than. Of course, we always use parentheses with infinity. And then I'm going to use parentheses around the 3 as well because we don't have an or equals 2 in there. There's no little line sitting there like that. So we have parentheses. So to represent this on our number line, I'm going to draw a big old circle, empty circle at 3. Because the empty circle always goes with the not filling in 3 with the parentheses idea. And then I'm going to mark all values going to the right and fill that in a little bit. Draw an arrow. And that's how I'd represent that inequality as an interval notation and then also on a line. Now, similar idea for x less than or equal to -5. We want all numbers less than -5, and we'll also include -5. So that'll be from -infinity up to -5. We always use parentheses with infinities, and we're going to use a bracket around -5 to show that it's included because we have that or equals to in the symbol here. So then at -5, I'm going to draw a closed circle. We're including -5, so we're closing it. And I'm going to shade everything to the left of -5. And that is how we represent that inequality. Now, moving on. We have -2 less than x less than or equal to 7. Well, that means I want all numbers between -2 and 7, and we're going to include 7. So that will be all numbers from -2 to 7. Parentheses around -2, it's not included. Brackets around 7, it is included. And this represents all numbers in between the two. Okay, so then I'm going to have an open circle at -2 and a closed circle at 7. And I'm going to shade all the values in between the two. Just like this. Now lastly, I have x less than 1 or x greater than or equal to 4. So I need numbers less than 1 on this side and greater than 4 on the right-hand side, including 4. Okay, so that's all numbers smaller than 1. So that's -infinity up to 1. And we use parentheses also around the 1 because there's no or equals to. And we're going to stick that together with a union and think about all numbers greater than 4. So that's 4 all the way up to infinity. You know what? I shouldn't have drawn anything yet. We draw the numbers first. 4 to infinity. Infinity, of course, has a parenthesis, and 4, in fact, has a bracket because we include 4. So anytime you see an or, you're very often going to have a union in between. Just keep that in mind. Now I'm going to draw an open circle at 1 because that's not included. Make sure it looks open. Then I'm going to have a closed circle at 4. Now looking at the first case, -infinity to 1, I want to represent all negative numbers up to 1 and not including 1. So it's actually going to shade all this stuff on the left-hand side here. Now for the other interval, from 4 to infinity, I'm going to shade everything on the right-hand side here, greater than or equal to 4. And I throw in my arrows, and that's what that one looks like. So sometimes we have one-sided number lines, sometimes we have a number line that is capped in the middle, and sometimes we have almost a gap in the middle of our number line. But go ahead and try for yourself the rest of this worksheet. And as always, reach out to me if you have any questions.